Hello, calculus fans. Let's talk about Green's theorem. This is a theorem that's going to give us the relationship between a line integral around a simple closed curve C. Simple means it doesn't cross itself. Closed means it's a loop. And a double integral over the plane region that's bounded by the curve. Let's show a picture. That's a simple closed curve. Simple doesn't mean non-complicated. It just means it doesn't cross itself. And then D is going to be the region that's enclosed by the curve. Now, in the statement of Green's theorem, we're going to use a convention about orientation of curves. So the positive orientation of a simple closed curve refers to a single counterclockwise traversal of the curve. So you go around the curve in a counterclockwise direction. Here's another way of thinking about it. If C is given by a vector function r of t, then the region is always on the left as the point r of t traverses the curve. Let's show a picture to illustrate the difference between positive and negative orientation. Now, both of these are simple closed curves. Again, simple doesn't mean uncomplicated. It simply means that the curve does not cross itself. The curve on the left is displaying positive orientation. The curve on the right shows negative orientation. All right, we're ready to state Green's theorem. Now, there are a bunch of hypotheses. The first is that the curve in question has to be positively oriented, piecewise smooth, and a simple closed curve. And this curve is just going to be in the plane, so everything that we're going to deal with here will be in the xy plane. And then D is going to be the region that's bounded by the curve C. And let's suppose that P and Q have continuous partial derivatives on an open region that contains D. Then the line integral over C of P dx plus Q dy is equal to the double integral over D of dq by dx minus dp by dy. This expression that you see on the right-hand side of Green's theorem looks somewhat arbitrary, but later on we're going to see a generalization of Green's theorem known as Stokes' theorem, and we'll see where this expression really comes from. Let's talk about notation a little bit. When we write the line integral of P dx plus Q dy, that's the same thing as writing the line integral of the vector field f dot dr, where f is pq. Also, once in a while, you might see this integral symbol with a circle through it to indicate that it's a line integral being performed over a closed curve. Even more specifically, sometimes you'll see that little circle have an arrow inside of it to indicate that the integral is being done over a closed curve and it's being done in the positive orientation. And finally, I think you should be thinking of Green's theorem as an analog of the fundamental theorem of calculus. Okay, that's all for now.